In addition to all of these mechanisms, Telethon also provides you with the ability to set up conversations. This is where I think we start to see that these wrapper APIs on top of a core API, they start to get a little bit hokey. If you look at some of the other third-party clients that you have that wrap on top of the Telegram API, they get really, really, really hokey when they start to deal with, okay, I want to have some bot that's able to not just echo something back, but be part of a long-running conversation where you say something and then you say something else and you say something else, and it knows where it is in the flow of that conversation. And if you ever used a Telegram bot, you know that's pretty common. Even with something like BotFather, you start the operation of creating a bot, and it'll ask you some questions about that bot, and you'll respond to those in turn. Well, personally, I think that a lot of the third-party APIs that try and give you some mechanism by which to set that up, some branching flow for that conversation, I think that just gets really, really clumsy very quickly, in part because necessarily that's probably something that you want to do with a generator coroutine. Thankfully, the Telethon API, by virtue of being asynchronous, gives you kind of the same general idea. That is to say, if you were to look at a asynchronous function, that asynchronous function is already taking each step of some longer task and breaking it up into parts. Obviously not the callback-based thing. You wouldn't want to do some sort of conversational API based off of like a new message where you set some state for where you are in the conversation. That would be a bad idea. But what should be relatively straightforward for you to do is a little bit of code that looks like this. You can send messages. You can iterate over all the messages that were sent to you as a client. And you can put this into an asynchronous function that looks like this. So here, this is your handler. You could run this handler and maintain state as just a local state in this asynchronous function where you say, okay, iterate over all the messages, see the messages, categorize them in some fashion. And of course, what you'd want to do is then scope this to one individual conversation. Well, the Telethon API gives you something kind of like that. You can do client.conversation. And this will create this conversation instance. And this conversation instance there has some methods for interacting with messages that were sent back and forth within the scope of that one conversation. What it's not doing is it's not setting up the back and forth itself. It's just giving you the ability to refer to. We do something like message here. Plus that one conversation. This would have been, let me await this. That'll appear in the one-on-one chat. Obviously, we have to do this with a user that exists. Our bot was called. And this will appear in our one-on-one chat with the bot there. Well, here we can also, we do a dir on the conversation. We can get the replies from this and get the responses. So we could say conv.getReply. And here, let's do a dir on or a help on getReply. And here, we're going to wait for, we need to actually get a previous message. Let's see if we can get response. There's a difference between these. So let's do a get response. And this will, and here we want to actually give this a message ID. So let's see if we can. We can send a message, get this message object. Let's get the response to that message. I believe we have to give this an ID, or is it getting a reply to this? Here, the error is that, and I think we might have to specifically give it a timeout. Let's quickly check the text for this. For the most part, these APIs are really, we usually just have to do a little bit of digging or find some example code for how these work. I think we might want to, let me see if I can apply to this. And if that'll give me something there, it might be failing, of course, because there's nothing available there, or I might need something other than the message itself. Let's quickly take a look. So we send a message, and we're going to await the response. Oh, so let's try that one more time. You can see sometimes these methods don't quite work the way we want, which is why we need some kind of rapid iteration mechanism. But we can see from the example code that they provide to you in the help text, more or less how they intend for you to use this thing. They intend for you to use this like a back and forth API, that you can more or less in that asynchronous function set up this is what I'm going to send you and this is what I'm looking back, and maintain the state of that as you go. When we talk about generators and coroutines, we'll talk about how we want to model any of these state machines. Oftentimes we want to do these automations. They're deeply stateful things. We'll want to manage the statefulness of these things in a way that you can actually make sense of and you can actually debug. But I want to take the time that we have remaining, talk a little bit about some of the problems that we run into when we work with these kinds of APIs. Here's a problem. One, I don't care about the Telegram API. I care about getting things done with it. I care about delivering some business value, making use of this tool, or making use of an automation on this tool. But largely, I don't really care that much about all of the intricacies and all the difficulties of this tool. Similarly, I'm not going to keep super up to date with all of the details of how the API evolves over time, or limitations of the API, or bugs in the API, or fixes to those bugs, even the state of the API servers. And I want to give you a couple of core principles whenever you're writing a bot or an automation, because I'm guessing you probably come from the same perspective that I'm coming from when I'm iterating over something like the Telegram API. Simply, I want to get in, I want to do a little bit of work, and I want to get out. I do not want to become an expert at the Telegram API because there's far more useful things for me to become an expert at than something like this. I want to narrowly identify what I'm able to do, go and implement something, deliver something to production, and then move on. Fundamentally, this is why whenever I'm looking at a new API and I see some third-party tool that has a very, very thick wrapper on top of whatever the core mechanics of that API are, especially if that wrapper is also wrapping over things like an event loop or over error handling, I stay very, very far away. There are multiple Python-based APIs that wrap, or multiple Python-based libraries that wrap on top of the Telegram API that you can use. And for the most part, I actually am very skeptical of how useful they are beyond small demos. Here's why. Generally, my principle whenever I'm interacting with the outside world is to isolate that interaction as much as possible. Reason for that is I really don't care about when that external API changes. I don't care when the API is down and then I'm watching for it to come back up. It's just an annoyance to me. I don't care when the API has changed. It's just more for me to do. I have other things that I need to do. And so what I want to do is very carefully isolate that API. I also generally don't really want to read through pages and pages of documentation for how to use one particular tool that promises to be really easy at solving something. What I want to do, I want to go find an example of something that somebody has done that's very similar to my use case and then synthesize from it. And so in the case of the Telegram API, especially since a lot of the wrappers try to give you something that is very different looking from the core MT Proto API, my suggestion would be stay away. The reason for that is we know that the actual Telegram clients are open source. We can go and find some of these open source clients. There was a competition done a while back for Telegram X, and you can find the source code for that. We can go and we can find a lot of examples of people making use of this MT Proto API and seeing what the actual underlying API calls are and what the expectation for how they're supposed to work is, what they return is, and how to structure common operations with these. We can synthesize from that into our use case, because oftentimes we don't want to do something as complex as, say, a native client. We want to do some very, very, very small subset of that where we're taking one or two examples and then jamming them together and then moving on with our lives. I don't want to do this in such a way that I need to go and identify, or I need to go and understand some additional conceptual framework on top of some additional conceptual framework on top of the core API, because the sample code that I'm synthesizing from might not be written using the Telethon Python library. It might not even be written in Python. It could be written in any programming language. And I want to be able to take some code that was written in C++ or in Rust and to see what those empty protocols are and to be able to say, okay, that's exactly what this maps to in my version in Python, and then move on with my life. In a very similar sense, I actually have to be very careful about things like error handling. One, in the Telegram API, we send requests, and those requests are actioned, and you can see there's some delay in how those requests are actioned. That is to say, when we change the title of the channel, it wasn't changed immediately in one of my clients. There's some delay associated with it. Well, generally, the response that we get indicates that there is a success or a failure. Are we able to actually perform that action or not? If we ask to change the title of a channel, did it actually change the title of that channel, or did it fail because we didn't have permissions to do that? However, note that the underlying API that we're interacting with could mislead us. It could tell us that an action succeeded when that action didn't actually succeed, when the action failed. And our only way for us to determine, well, is it really telling us the truth, or is this some bug that I need to work around, is either one, we ask the underlying tools that we use, the intermediary between us and the Telegram API, to implement some sort of complex back and forth. Okay, you said that this succeeded, go and check to make sure this actually succeeded by adding some additional API calls. But generally, that kind of error handling, or that dealing with the situation where the API has some imperfection or some bug, that kind of workaround, tends to be very ad hoc. It tends to be something that exists at some point in time. That's often just a workaround to fix one small thing that you noticed, and you move on with your life. And generally, whenever you see some sort of intermediary level, try and deal with that. Basically, whenever you see an intermediary do anything but just feed you what the error messages are and let you figure out what to do with the error messages, very likely that's going to trip over itself. It's going to get in your way. It's going to prevent you from either ignoring errors that you simply don't care about. For example, if the action failed, I don't care. I try it anyway. Because maybe you wrote extremely naive code that just tries actions and then doesn't care if they succeeded or failed. If they succeeded, then that's good for your case. If it failed, then maybe it wasn't relevant for what you were trying to do. You just don't even bother to make the distinction between those two. Or, if not get in your way, they might, in fact, add additional layers of complexity, because you may need to know that something failed and then perform some action on top of that. So when you look at all of the different choices that you have for bindings from that core Telegram API, that empty proto API, into Python, what I think you really want to look for is something similar to Telethon. You want to look for something that is as close as possible to the underlying entities that you have, the actual message calls, that exposes all of that error handling for you, and gives you the ability to put in one additional layer of indirection. Here's something that I want to note for you that you wouldn't see in this example, and you'll see something of a pattern when you write these simple automations. In general, most of these automations and most of the APIs that you'll be working with, whether it's the Slack API, the Discord API, the Telegram API, they're often written in order to support simple demos. So you can see like a 10-line demo that does something simple like an echo server is very easy to write. And you wonder, well, where's the difficulty? I could do this in an afternoon. And 6 months later, as you realize that the original 10 lines of code that you've written have exploded to 10,000 lines of code, you're scratching your head and you're saying, where did everything go? Well, where everything really went wrong was when you take a look at these APIs and you try to understand how to situate them into an actual business process, an actual, something that needs to run in the background, that needs to run without any attended operation, that needs to run if, for example, like what happens if there's an exception that occurs in between one of these two steps? Am I going to put this in a giant try and except and then log back in? What if it's the case that my client session gets invalidated. We can do that in Telegram. We can say invalidate all of the client sessions that are available. What happens if my client session is invalidated in between this message and this message, or in between getting a message and actually sending it back out? Well, in all of those cases, we can see there's all sorts of Byzantine errors that we can deal with. And for the most part, when we're hacking something together in 10 lines of code, we're just pretty much ignoring those. Where I think you want to be very parsimonious and very careful is thinking about where you add additional layers of indirection on top of this. And so if I weren't creating a simple demo, but I were creating maybe a larger framework, maybe a larger framework for creating channels, adding users to those channels, sending some messages back and forth, maybe after some point in time expiring those channels, maybe this is a customer service example, we might think, should I just take all of these API calls that I can see via my dir and my help method and just write them out and have one 50-line script? Maybe not. Maybe what I actually want to do is first model the underlying problem in as little code as I can in Python. That is to say, we can think that if we were doing a customer service example, we may find that our very first piece of code is not actually Telegram API code. It's actually modeling the underlying problem, say using a collections name tuple or a data class to represent what we're trying to do. So here we could say customer service incident. And capturing some of the data associated with that. Here's the customer, and you know what the date is, and then the text of this. Setting up all of the things that we need to do as part of our workflow. For example, this thing might need to create a channel. This thing might need to expire that channel after some period of time. For example, if that event doesn't get action after some time, maybe it gets kicked up. Maybe this is an escalation. So this is creating a channel for, which tier of this is, which tier of customer service that you're responding to. So maybe if it's tier 1, then you have one channel for that. And then once that gets escalated to tier 2, maybe you invite people to this one channel, or maybe you close that channel and you create a new channel, or maybe you use the new topics feature to create a new topic, whatever the case may be. You model some of those pieces. And then in parallel with modeling this out in pure Python, without any mention of the API itself, you do small prototypes like what I showed here. You write a small prototype to say, what do I do to invite people to a channel? Well, we know we can go into that telethon.tl.functions.channel, and you can send an invite request. What do we do to remove somebody from that channel? Well, we saw there was a kick participants. What do we do to send messages about the request to the channel, or to listen for messages and then take responses from that? For example, if somebody sends a special, you might have a send email. You might connect this up to an email server. So if somebody types a message with a particular tag that sends an email to the customer, and then when the customer responds to that email, it pastes it back into the channel. So you can unify your use of Telegram and emails. Whatever the case may be, you mock this up in pure Python and then write very small prototypes against the Telegram API. And then at the final step, you connect these pieces. And for the most part, the connection of these pieces may just be connecting this with an API call here. So you might do something like, your Telegram client, you might pass in client object, or you might even intermediate that client very slightly. You might even have something that does a lot of these common pieces for you. You might say this is our API client, and this gives you the Telegram client. And then you add some set of methods here for, sending an email and retrieving an email. And then you connect those pieces together to the mockup that you have, the framework that you have for your underlying code. The reason why you might choose to do this is, one, you could iterate very quickly with something like the Telegram API at the incremental portions of this code. The how do I send a message? How do I rename a channel? How do I add somebody to a channel? How do I remove somebody to a channel? Except you can see it's a little bit clumsy. In part, we can't use our typical automation approaches where, for example, we have a code block and we run that over and over because we'll hit rate limits. For example, we might be limited in other ways by the API, but we can do that interactively. We can find exactly those lines of code, and it may take us a couple of different tries to find the exact 3 lines of code to perform the action that we want, but we can definitely iterate on that separately. We can write much of this code without ever needing to interact with the outside world. And we've created a very clear hinge that separates the part of this code that we completely control, that is the modeling of the problem that we're trying to solve, and the part of this code that we don't completely control, that is the outside world, how that API works. And it gives us a little bit more of an opportunity to, for example, clean things up or work around, put in some dirty hacks if we need to hack around some limitations of the API, or if we need to, for example, make small little spot fixes when something goes down, or make use of on our own schedule changes to this API where maybe we can consolidate different behaviors. What I wanted to show you in this session was an approach for interacting with the Telegram API. For the most part, if you make use of a tool like Telethon, it's actually very easy. There's a lot of complexity behind how Telegram itself is structured, the difference between channels and chats and groups and supergroups. But for the most part, if you think about this as just a messaging service and you think about the kinds of automations you want to create with that messaging service, automatically creating groups, adding people to groups, removing those groups, changing the group information, messaging people, responding to those messages, this really is only about 5 or 6 different API calls. And in the course of maybe 30 minutes, you can quickly get a handle on what those API calls are and how to situate those into a program.